postgraduate student of computer science at OAU. My question, the presenter did a very good job about the topic and the project they did. Is very practical, because the issue of potholes and roads, like the issue of potholes and roads because of the asphalt use, is a very crucial issue that needs to be solved. But the presenter did not tell us about the existing methods used. And then I want to know the novelty of this method. Are you the first person using this method, or there is maybe some people have used this method in the literatures already? So thank you.
Number two, everyone. My name is Adam Solafemi from the Department of Engineering. I'm a visual student. So kudos to the presenter. Then regarding the reclaimed asphalt pavement, my question is, was the condition of the reclaimed asphalt pavement put into consideration, like the aggregates, the binder, how long the asphalt has been used, because it is waste. So regarding that, I want to know if that was put into consideration. Then the lime that was used as an additive, the percentages that were used, why did you pick those percentages? Then regarding the cement as well, there was a chronological order to it, like 1%, 2%, in which you use the cement to replace the filler. So I want to know why that percentage was used. So that will be all.
Number three.
That's Engineer Mustafa Musa. It's a good job. The problem I have with your presentation or your work is the methodology. Because when you look at the algorithm, you did mention some materials that you were varying, in percentages. I'd expected that you will use a kind of design of experiment to make your work robust, so that when you have independent variables, of course you have independent variables, dependent variables and independent variables, and this will translate to the plots that you are giving us. And I'm actually surprised that you were able to come up with these plots that you brought about by the use of design experts. It makes the whole thing look clumsy to me. So I would have expected that you employ design of experiment to make it clearer, so that we know what you are doing exactly. Thank you.
I believe the presenter.
Yes, sir.
I will, so as to save time, you answer questions 1 and 3. Question 2 seems to be embedded in your next paper that you are going to present now. That's the evaluation of asphalt pavement materials, something.
Yes, sir.
So answer questions 1 and 3 now.
Okay. Thank you very much. This very interesting question. The method I use, just user response service method. I'm not the first person using them, but they have different methods inside. There are 3 basic methods. What I employ, the difference of my own and the other ones is based on the materials. I am testing the wrap as the layer of wearing cost, not as usual some base or base cost. So, and also the method I'm using, custom method, is quite different with the other people that have been using different methods of compaction, or gyratory method, and some other ones. So I introduced a novelty of lime calcium hydroxide so that it will attack some of the challenges of these cold mixed asphalt of the weak bondage. That is what I introduced that one. So, and also the design experiment I didn't put all the dependent variables at once. First of all, I used a matrix design job method. There is a matrix method that I was increasing some of the factors consequential. It was after putting all the cement aggregates and other things I put. Later on, I got the optimum emotion content with keeping RAP at 0. It was after getting the optimum emotion content. Now I use that optimum emotion content and start varying the percentage of RAP inside from 0 to 95% until we see the responses where it's. And the second method also, even though I am about to present that paper, so that is talking about number of years. The number of years is an old pavement that was sourced from Abuja, Kaduna, Abuja, Julius Baja's site, and the materials have spent over 25 years, but it was all the laboratory tests have been taken and tested the aggregate, and they found to satisfy the requirement. And all those cements that we are varying, the filler, we use 0 cement first and use this crushed stone. But later on, because we know the cold mix asphalt is having issue of weak strength gain, so that is where we started replacing the filler by 1% to 7%, and you see what is happening. Thank you. I think I've tried my.
Thank you. I believe we will hear more in the next paper, still addressing these questions. So you can now continue with your second paper. That's evaluation of asphalt pavement material properties using reclaimed asphalt in cold mix technology for wearing costs.
Mr. Chairman, sir.
10 minutes.
The distinguished participants, good afternoon, sirs. My name is Yaman Musa. I'm here to present a paper evaluation of asphalt pavement martial properties using reclaimed asphalt cold mix technology for wearing costs.
Share your slides, please. Share your slides.
Yes, I am. Are you seeing?
Yes, start from the first slide if it's the same.
Okay. The evaluation of pavement martial properties using reclaimed asphalt cold mix technology for wearing costs. Introduction. There are basically 4 types of asphalts. We have hot mix, we have warm mix, and cold mix. And cold mix asphalt technology is the most sustainable technology green available for the construction of flexible pavement to date. Eco-friendliness, energy efficiency, and cost effectiveness are major drivers responsible for cold recycled asphalt mixes being considered as alternative to hot mix. Sustainable road construction practice is founded on 4 pillars: satisfactory performance of pavement during the design, environmental friendly technology, minimize utilization of money, and the construction should be favorable to human safety and comfort. According to Infrastructure Concession Regulatory Commission, Nigeria has about total road network length of 195 kilometers, out of which that's 195,000 kilometers as the total, out of which 32,000 kilometers are federal roads, while 31,000 kilometers are state roads. About 135,000, which represents representing 70% road network in Nigeria are untapped. Minister of Works and Housing, Engineer David Omai, we were reported to have said on we need about 14 trillion to fix it is 2,604 projects, total of 18,000 kilometers. This was aired on 18 September 2023. Then, before then, during the former Minister Babachinde Fashila, one meeting with the House of Representatives, you also mentioned 1.3 kilometers, 1.3 trillion fixed road. So between his regime to that, you can see the difference of huge amount of variation. We cannot continue like that. We have to find out a solution, what is the sustainable method in terms of cost, also the health-wise, sustainable materials that will replace our road. Our deplorable road conditions are really not bearable by the day. This research is aimed at evaluating the martial properties of colmix recycled asphalt pavement. Previous researchers like Ismail et al., Argaiti, Alsavi, Seviu, and Nabiu, Flores et al. Also work on similar areas. But the only difference of this research with their own is working on colmix recycled asphalt pavement for wearing costs, not base costs, not sub-base costs, not stabilization. And we are applying Marshall method, not like the directory compaction method. The material is on the board. We have recycled asphalt pavement sourced from Julius Bader sites, Abuja, Kaduna Road. Aggregate were accessed from open market. Lime, calcium hydroxide, sourced from open market. And the cements, then cationic emulsion sourced from calcium emulsion plant. The method, tax 1, conducted physical and mechanical property tests on fresh aggregates to find out the suitability. Now conducted physical property tests on cationic emulsion and lime. First of all, we use all the materials are not put at the same time. We casted 75 number samples using fresh aggregates. We use granite dust first as filler. Then we keep replacing the percentage of filler with cement from 1% to 6 and 7% as replacement. Then because we are targeting wearing cost, the minimum percentage of bitumen is 5%. It's from 5% to 7%. But this is an emulsion, though we vary from 5%, increases 0.5 to 11%. And we get the optimum emulsion content. Lime also, we introduce lime to address the weak bondage between the leaves. There is pre-wetting water that is varying from 1% to 2%. Optimal emulsion content and pre-wetting water content was established using Marshall method first. Then, after that 75%, having established the optimal emulsion content, and then another 30 samples were prepared. The first 75 numbers, RAP was not introduced. In this new, now that we know the optimal emulsion content, we started using the RAP of 0% to 95%. Marshall stability and flow test of each sample conducted and recorded, and the volumetric test of each sample conducted. The test under result and conclusion and discussion, we subjected all the material to the test and using ASTM method. They are found within the standard standard. We also take the graph and run the average crushing value on the physical properties, water absorption, and we found it within the specification. Now, there is a...
You have 3 minutes more, 3 minutes left for you.
Okay. The envelope, the gradation also for all the materials are within the farm. These are the graphs that were plotted using different percentage of filler and as a cement. The first one that you are seeing, filler 3 plus 2 cement, we use the granite 3% and we use cement 3%, granite 2%. As it is going, you can see the stability. As the percentage of cement is increasing, the stability is increasing. This is not unconnected with the percentage of calcium and rest that's inside. And this graph also is showing the bulk density. As the emulsion is increasing, all the bulk density is increasing. Also, this one is for the total void content that is shown as the cement is increasing, is the void is reducing because it's filling the void. This Marshall volumetric properties that is showing the effect of percentage of cement. Conclusion. Pure granite dust should not be utilized as filler for any pulp mix because it has failed. Minimum of 3% cement can be utilized for production of pulp mix recycled action pavement for wiring costs. Then 8% emulsion content and 0 lime content should be adopted as optimal value of any pulp mix recycled action pavement. For utilization of raw material, not more than 30%, 3% cement can be used as filler. While for utilization of rock up to 70%, minimum of 5% cement must be used as filler. And finally, for utilization of rock up to 95%, minimum of 6% cement must be used as filler material in pulp mix circulation. Thank you for listening.
Thank you, Mr. Presenter. Thank you for managing the time. Now, note the questions. You are going to answer all of them once again.
Okay.
Please, questions from the participants. Number 1. Any other? Okay, number 1.
Once again, kudos to the show. Kudos to the presenter.
Are you hearing him?
Yes, sir, I'm here.
Okay.
I'm here.
So, regarding the reclaimed asphalt pavement, I believe there is already existing. Sorry. Okay. I believe there's already an existing filler in the reclaimed asphalt pavement. So, in your presentation, you mentioned that you introduced the granite dust into it. Then you now replaced it with cement at different percentages. So then, back to the lime, like I mentioned. You said you used it as an additive to improve. Is it to improve the whole reclaimed asphalt pavement, or is it a particular component in the reclaimed asphalt pavement that you used it to improve? Then, to the conclusion, you said that pure granite dust should not be used for cold mix recycling. You didn't tell us why. So that's all.
Number 2.
Good afternoon, everyone. Adeton Ayodej is my name. My questions are the slide that shows the methodology. Is there a way that the presenter can expand on the methodology, because the slide is too compact? It's not that clear. Number 2, then that is on literature review. I can't see more literature in this work. That's the second. Number 2. Then the third is, what is the contribution of this research to the body of knowledge? Thank you.
Did you hear him properly? That last question, then. So go on answering them.
Thank you. It's a very interesting question. The issue concerning RAP that it has a distinct filler inside. Actually, we are not considering patterns. This is called mixed recycle asphalt. And when you are dealing with it, when we are applying that, there are 3 instances that we can use it. It's either, if we want to consider the RAP inside, the filler inside RAP, we have to introduce what is called a rejuvenator. The rejuvenator will rejuvenate the filler and make it active inside the mix. But this one we are not using rejuvenator, we are using RAP as just like aggregate. That is the method for this one. Then the second aspect of question that is why are we using RAP? What is it for what? Basically, the challenges of the economic action. The first challenge is the high percentage of void inside. Then the second one, it has weak bondage. And this weak bondage, that is based on the literature we discover when we use lime as additive, is increasing the bondage. That is it. And the third one that is speaking about granite. The granite, the first sample we use, series of samples we use in the laboratory, we use pure granite. But after immersing it in water and heating it at 60 degrees centigrade for like 2 hours, they melted. Because there are no proper bondages and the void inside is high. And that is why we replace the granite with cement to fill in the void and also make it very strong. So based on the findings, we found out that granite will not work, doesn't work in cold mix, pure granite. You can use some higher percentage of cement and put low percentage of granite inside. Then the question of filler, okay, methodology. Yes, maybe it's noted. This is a little bit clumsy. There are enormous time to present. But actually what we are trying to explain to you, the chronological stages we follow. The literature review, I think I have much of literature review in the paper. If you check, I am sure they will, if you have the proceedings, you will see much of literature review there. We have it, and the current one. Then the contribution to knowledge. Now, to all contractors and consultants, we can see based on our experience, we have higher percentage of roads that are bad, and the government cannot fix it because of the variation all the day. We have to get sustainable material. But at the end of my findings, we discover that if you are using emulsion, first of all, the contribution to knowledge is done there. Allow using cold mix in your site or somewhere with pure granite as filler. This contribution to knowledge. And also, if you want to use RAF, what type of percentage? If you want to use RAF, there are percentages attached. For example, like this number 4, if you want to use percentage of RAF as 20, and you are considering 1% of cement, it will fail. Then, if you want to use higher percentage, like 70%, your percentage of cement will be higher. And also, the optimum percent is like 95, your percentage of cement as pillar should be 6%. You also see the minimum percent of this ring can be utilized for production of coal mix recycling. I think these are the contribution to knowledge to any practicing or even contracting, that the coal mix can work. It's not necessary we use hot mix, but there are challenges. We need to know the component, the mixture, the percentage of components, how they are behaved. Thank you very much.
Thank you, our presenter. Let's clap for him, please. So, thank you. Observation for him. Hello, are you still there?
Yes, sir.
Please listen to this observation.
Yeah, maybe it's a slip of tongue when you are presenting. In the body of English language, there's no word like casted. I think I heard you when you were saying casted. Then, what the last man that asked question was trying to point out, when you are presenting your graph, if you look at those graphs, they are so clumsy because you are putting graphs and table together. It's either you present your results in table or in graphs. So mixing the two together makes the whole thing complex. And the graphs are not so distinct because you are putting table there. It's just sort of observation.
Thank you.
You can go and listen to the remaining presentations. So don't go.
Yes.
Thank you.
Yeah, yes, sir.
And your colleagues there too. So the next presentation will be on characterization of the bottom ash of the Lafia will be coal. A.R. Ajewale, B.V. Midiji, and A.O. Oluwajobi. Is the presenter here? Are you the presenter? Where is the title? Is it there?
Yes.
What is the name I'm seeing you? I see. Well, no, if you are seeing it, you are the audience. That's okay. I see the color contrast.
The chairman, sir, and Victor Omidiji. I represent these researchers, Ajewale, Omidiji, and Oluwajobi. We are presenting the topic, characterization of
Please raise your voice.
of the bottom arch of the Lafia of the coal.
10 minutes you have.
Next slide, please. Yes, Nigeria is blessed with coal. That is why we have the coal city, Enugu. And we have deposits in Kogi, in Nasarawa, and some other places. But this bottom ash that we are looking at is one of the residuals when we burn coal in a soil burner. Okay, in a burner. When we burn it in a burner, it's one of the residuals. So, and it compares much in terms of demand with fossil fuel because it is cheap, it is abundant globally, and is used to generate energy. That is the situation with coal. But the residues that we are having from burning coal, we are isolating the bottom arch. And we want to try to blow it open by characterizing this bottom arch so that we can know what to do with it. Next slide. So what can we do with this bottom arch that we are having as a result of the burning of coal? a group in my department has done research by, generating energy from coal, burning coal in Swebona. And then we look at the bottom ash. What can we do with this bottom ash? We should not just throw it away. Now, look at some of the applications among so many. We have just listed a few, in road construction, block production, and some other ones. But the area of interest to this group is the last one. That is the refractory coating additive. We are not presenting that here right now, but we are only looking at the characterization. Next slide. Now, on the issue of environmental and safety concern, well, it will be of concern to us as regards what could be the impact this, residual can cause in an environment, because we are looking at a situation that whatever we are doing must be eco-friendly. And that is the reason we are taking on this research that we should characterize the bottom ash. The next slide. So, how do we go about it? Methodology. We sourced for this coal at Lafia in Nasarawa State, and that is where the name came from, Lafia Obi coal. And then the sample was heated at a temperature of 950 degrees Celsius, in enclosed kiln in burner. And we went on to do the analysis by SRD, and then by looking at the chemical composition, and then looking at the TGA, and then the ultimate analysis. Now, we have the results. For example, the XRD is depicted in figure 1. Let us see figure 1. Now, this is figure 1. When you look at figure 1, you will see that the sample is enriched with quartz. And we all know that quartz has, high refractoriness. And for those of us that, have interest in foundry, quartz will be of interest to us. And that was why I mentioned the other time that, yes, the area of interest for us is to develop a kind of refractory coating that will help in our work. Let's go back to the last slide. And then we are able to get the chemical composition, of this sample. And from the analysis of the chemical composition, the three top oxides in this sample, you will see silicon in the oxide form, the aluminum in the oxide form, the iron in the oxide form, making, a combination of 85.04%. And that places this sample in the classification of F as, according to ASTM classification. And what does this tell us is that, it's going to be useful in post-ceramic, activities. Those of you civil engineers your curiosity will be aroused now that can it be a replacement for so and so. Please don't ask me. I'm not a civil engineer. Next slide. Yes, this is the chemical composition. You see the oxides present. And then next slide, please. Now, the loss on ignition. Now, here we see that the loss on ignition is quite high. It's beyond what the recommendation of ASTM says, because the recommendation of ASTM, its recommendation is quite lower than 10%. And there are presence of heavy metals, barium, copper, chromium, nickel, and so on. And the zinc, nickel there. which could be harmful to the environment. But even at this, are we going to say that the bottom ash is actually not useful? Of course, no. Next slide. Now, this is the result of the ultimate analysis. Now, we take it one by one. Let's look at the carbon content. The carbon content is 60 point something percent, and which indicates that it has a high eating value. The low sulfur content shows that it poses, low risk to the environment. The nitrogen content signifies low potential for generation of pollutants, such as the oxide of nitrogen. But the oxygen content, which says is 33 something percent, shows that, well, the higher the calorific value of the bottom ash. Okay, sir. And then the hydrogen content is telling us that the higher the hydrogen content of the bottom ash, the higher the calorific value. Now, this is the ultimate analysis. Now, what are the observations that we can make from the TGIL experiment? Let's go to the graph, the next slide. I think that's, yes. Look at the graph. You will discover that when it is charged to the system, it's stable up to, like 200 degrees Celsius, and then it begins to degrade, and, in a steep male, until it comes finally to rest at around 500 degrees Celsius. This is the behavior of the TG. The next slide. So we want to submit that the 85.04% of the oxides of silicon, aluminum, and the iron present in this fellow we are considering makes it, in the classification of F according to ASTM, and then the low content of the sulfur, the nitrogen, suggests that the gases that are associated with this are not that hazardous. And then the number 3 is that the LOI, which is above the recommended value, calls for caution, is of concern. And then we want to conclude that this Lafayette OB coal has high calorific value. For those of you that will generate energy, we are not so much interested in that in my group, because what we are looking at is for this thing to create a barrier between our pattern, if it is an evaporative pattern, something, and then the advancing multi-metal, because it should be able to resist the shock, when an advancing metal is coming, so that we can have a kind of surface integrity that is, that is sound, and then the mechanical properties of the casting that we are going to make will also be good. Thank you.
Questions? So there is only one person. Okay, and I'm the only one person. Mr. Presenter, thank you for your presentation.
Thank you, sir.
That's your TG. You did not explain it very well. The thermogravimetric thing. That's one. 2, in the composition analysis, you showed us the oxides that are there. SiO2, AlO2, and some other oxides. Are they present as those oxides or as aluminosilicates you did not tell us. I believe SiO2 silica especially, while there will be free silica in the aqueous, there will still be aluminosilicates there. XRD that you did showed us quartz, and that's what it will do. It will show us SiO2, yes. But what about aluminosilicates? Because I believe there will be aluminosilicates there, maybe in form of clay or some other things. Not necessarily clay, there are so many aluminosilicates. So we may want to know how those oxides exist. So maybe some other analytical methods, like chemical, even XRD should be able to show us those things. And your TG, please. Thank you.
Just an observation, like he said. Well done, Mr. Presenter. The classification of the fly ash as class F, whatever the ash, or as class F fly ash, you use the silica. I think it should classify based on the calcium content. It's the calcium content that would determine if this ash is class F or class C. Because you didn't give us the calcium content of the fly, of the fly ash or the bottom ash. Thank you, sir.
Well, this is just on the lighter mood. I don't know why did you carry out this research? Are you a metallurgical engineer or a mechanical engineer? It's just, I know that he's a material person. We are going to be inviting him to come to our department, but he still stayed in mechanical engineering. I don't know why, he decided to stay. But he has done a good job in, well, I know the HOD is there. That's why I'm standing up and I'm also saying what I'm saying. But on the lighter mode, we really appreciate the work. You have done a yeoman's job in the analysis. But of course, you need also to probably consult some of us who have done fuel furnaces and refractories under Professor Adoyi to be able to analyze the work well and put a fine touch to it, a finishing touch to it.
Thank you, sirs. To where we normally do run all those experiments. Is the result they give us that we take. Even at times when they give us the result and we ask them, what is this? They don't even know. No, we know what we want. We know what we want. When we query it, they will say, is that not what the machine gave now? So we make do with what we have. So the aluminosilicate now that the chairman is saying may be present that's probability, that's present. But we cannot speak to it because we are not looking, we are not seeing it. And as regards the classification, those, if you, please, Mrs. Dr. Ayodele, if you look at the submission of ASTM, they take these three oxides that I've mentioned. That is what they always refer to when they are going to classify. Once the combination of these three is more than 70, they take it to be F. Once it is less than, they take it to be C. That is what we understand. Maybe the metallurgical people will, But then, going to the last one, am I a mechanical engineer or, I'm a mechanical engineer, first degree to PhD, but the interest is in materials, and that is what we have been doing for many years now. The TGA, Prof, the TGA, the TGA, Prof. That is the result as obtained. In fact, the performer of the experiment, you know, if we had done this experiment by ourselves, it would have been a different thing. You don't know the conditions, you don't know the environment, how the thing was charged into the system, the precautionary measures. All these things are factors affecting our results. And it is what we see that we are going to speak to. I'm sorry, sir.
I just want to comment on the question of the chairman. I know we were talking about the XRD pattern, that there should be aluminosilocates. Actually, there is zeolite there. And zeolite generally are classified as aluminosilicates. You know, majorly, if you look at zeolite, we have different types of zeolites. Now, depending on the ratio of the alumina to silica. So I want to guess as much that that aluminosilicate is being classified as zeolite. So there is zeolite on the XRD pattern. That's just my own idea. Maybe they classify that as the aluminosilicates. Then, sorry, on the issue of the class F, maybe we have to go and look at it again. I don't know. Maybe it's the, maybe class F most times, or class C is based on calcium. But maybe this is majorly pozzolanic and cement. So maybe we can look into that later and see. Yeah, it's pozzolanic. Yes. So maybe you can look into that again and look at the method of classification very well. Maybe that is right or not. Thank you.
Chairman, okay.
Thank you very much, Mr. Chairman. I just want to continue from where she stopped. Actually, the bottom mash, the fly, they are all pozzolan. You understand? Because they have the silica oxide, aluminum oxide, and all that. But the class, to say that the class F, class C, they are pozzolans. But how do you now know that this one is a class F bottom mash or class C bottom mash? It now depends on the calcium content. Because for the class F, it usually have a calcium content of less than 10%. So that means it's not, you cannot use it as standalone. Like for example, those of us that use soil stabilization, you can't use it as standalone to stabilize your soil. But for it to be class C, maybe the calcium content is more than 20%. That means it has cementitious properties. So you can use it as standalone stabilizer for your soil or for use in your cement. Thank you, sir.
You know, that was the reason I told you the other time that this will arouse the curiosity of civil engineering, and that you should not ask me because I'm not a civil engineer.
You see, ladies and gentlemen.
We are actually discussing something here. Research has no barrier. I think this really calls for collaboration. Yeah, in fact, if you look at this topic, in fact, it cuts across even my department, chemical engineering, mechanical, materials, civil. So we cannot come together to work on this kind of research. So this calls for collaboration. We should all come together. As many of us that are working in this kind of area, let's come together and bring out a good topic or a good work, and that will really, that everybody will like, and then really develop our community. Thank you.
Thank you. You were reading my mind badly, what I wanted to say. But you see, nobody was ready to ask you questions. And yet you have generated so much heat. Yeah. You see, when you are doing characterization of any material, there is general characterization, then characterization for specific use. You bear in mind what is this material for actually, and that's what should have led you to collaborating with some other people. What property should a material for this purpose have? You now look at your own material, does it have it? Then you shut yourself in the foot as a researcher. And that excuse you gave, please don't say it again, no, like to anywhere, anybody. It is enough to disqualify that paper about, they just gave you results. You don't know what is in it. You gave your sample to some people to do, and they just give you results. It's enough to disqualify the paper anywhere. A researcher should be there when your sample is being run. You should be there. It's not that you just submit it. That's one problem you have when you just submit your sample, maybe you send it somewhere for it to be run for you. But where you have the opportunity to be there by the machine, you need to know the parameters input into the machine to use. You see, some machines are, excuse me, what do you call it? To detect some, the sensitivity, yes, up to a certain level, which you may not know. And you will come there to be saying, yes, it doesn't contain this at all, which may not be the case. It may be the sensitivity of the machine is put at a level which is higher than the quantity of your material that is in there, or of that particular material that is in there. And this XRD, did they identify all the peaks there? All the peaks. So when we are talking of aluminosilicates, yes, they said zeolite is there. How much of zeolite? Did you do the percentages of this thing there? Each of these oxides. Yes, from XRD you can get the percentages if you want. There are some methods of doing it of each of these oxides. But as I said, the percentage of aluminosilicate there, maybe zeolite as mentioned, which we have alumina and silica there, and probably water of hydration there. So, and you will have free silica. It's almost everywhere in the world, free silica, SiO2 as SiO2. So, combining the two, aluminosilicate, silica in aluminosilicate, and free silica, what is the percentage? So, if you don't note that, you may be getting wrong results, and that already we know the source of the problem, as you have mentioned. But the caution is, please, when you are doing a serious research, not just undergraduate students, this thing, be there when they are running your samples. You see, we have had situations whereby we sent samples to South Africa for them to do, what was it? Was it exactly or something like that? And when the results came, we know that no, this is not correct. We know. I don't know how they did it there, or maybe it was a mix-up or whatever. So please, even this SCM, okay, we are not the one that did SCM. Why you there when they are doing it? It's always advantageous. Now that the machine is here, sit by the side of the operator. You will be able to say, please zoom in on that feature we are seeing. I want to know what it is. Please do the EPX of that spot. It's always helpful. Or I want a larger magnification. It's always helpful. So don't shoot yourself again. Let's clap for our presenter. Now we have only 1 hour. And we have that. Yes, we are to, for this session. And we have about 2.5 papers more. 2.5 papers more. So, paper is strategic technological analysis of the liquefied petroleum gas retail industry in Ile-Ife, Osun State. Ogun, Dari, Ilesami, and Bakari. Yes, presenter is here. Good. 10 minutes, I hope you won't generate this much heat.
All right, thank you very much. Good morning, Chairman, and all the participants. Okay, I'm presenting on the topic a strategic technological analysis of the liquefied petroleum gas retail industry in Ile-Ife, Osun State. These are the authors, Ogundari Ilesomi and Bakari. My name is Olajoke Ilesomi. Energy, as we all know, is fundamental to human life and for the development of any nation, as it affects significantly the gross domestic product and the human development index of any nation. Energy is useful in every sector of a nation: the industrial, the commercial, the residential, and the transportation sector. In cooking, energy, okay, let me wait for the slide. All right, thank you. So for the residential sector, cooking accounts for 90% of the energy that is being used in the residential sector. Biomass has been what is widely used in developing countries as all right. So biomass is being used majorly in residential sectors in developing countries, and that includes the wood, charcoal, agricultural waste, and animal dung. But in developed countries, they are focused more on clean cooking fuels like electricity, LPG, and biogas and biofuel gels. Other factors that influence the choice of cooking energy includes the income of the household, the trend, the ease of use, accessibility, the cost of energy, and cleanliness. All right. Okay, I'm sorry, the slide being used is not the one that is supposed to be used. Sorry about that. But it's okay.
Is it the same paper?
It's the same paper, yes, sir.
Go ahead.
All right, thank you, sir.
Time is going to fast going.
Okay, so for LPG is a clean energy. Fuel, which has less environmental impact. It's energy efficient. It saves time. It has less health hazard also. But for the biomass is usually dirty, like in the use of firewood and coal. The drive in Nigeria presently is to achieve clean cooking like in the developed countries, and to get to be able to use clean cooking as much as other countries. In spite of the recent improvement of the LPG sector, there was a time in about less than 20 years ago that the LPG was just 50, LPG use was just about 50, was only about 50 metric tons, but now by 2020, 1 million metric tons of LPG is being used. Though there are so many efforts from the government to improve the use of LPG and other clean cooking fuels in Nigeria, the rates of consumption is still low. The Ife zone was purposely selected because of its complex regional dynamics in the state. Due to its population, it is the highest in the state of about 500 people in the Ife region of the state, and it also constitutes. It has the federal government institutions like the university and OAUTekConf, though it is a rural setting, but yet because of the federal government institutions, there are also influx of banks and other private institutions as well. So that makes the population to be dynamic, having civil servants, students, and also the rural community people in the locality. The methodology. This study utilized an energy planning and technological foresight analysis using the technological parameters. For this study, the technographic parameters analyzed were the classification, the number and location of LPG retail outlets, their techno-economic characteristics, the LPG total cooking energy demand, estimated cooking energy demand, the carbon dioxide emissions. The study area. If a zone was purposely selected because of the population, method of data collection. The data were collected from the National Bureau of Statistics, the Department of Petroleum Resources 2018 publication, LPG Retail Association in Osun State, the Energy Commission of Nigeria repository, websites of the Osun State government, related energy research articles, and industrial process calculation textbooks. Combined survey and interview technique was used to obtain the selected technographic data from the identified LPG retail outlets, and there are 2 safety assessment questionnaires that were administered to the respondents. The data were analyzed using industrial process calculation, descriptive statistics, Google Maps for geospatial imagery, and carbon emissions calculations and carbon emission calculations where necessary. Results and discussions. All right. The estimated cooking energy consumption in Ile-Ife, the population of the study area was estimated at 476,000 people, and the number of occupants per household was estimated based on literature to be 6 people per household, giving us a total of 79,484 households in Ile-Ife. The estimated energy demand per household per month is 580,650 BTU, and the total cooking energy demand per month, not just for the household, for the whole area, is 46,152,000 BTU. So the LPG equivalent for this is 993,550 kg. If the whole area was to be using LPG for their cooking energy. Alright, based on the DPR classification, there are 5 categories of LPG retail outlets. And that is the first one is the LPG refilling plants. Those are the ones with 5 to 300 metric tons. In Ile-Ife, we have just 0. There's none of it in the study area. Then LPG refilling plants, underground storage tanks is also the same size, having the same storage vessel. There's none of it in the area. Then LPG industrial storage category A are the ones that their storage vessel is greater than 500 kg in a fixed vessel. There are 6 of it. Yes, sir?
2 minutes more.
Thank you, sir. So there are 6 of it in the study area. And the other 2 categories are the LPG add-on in retail stations. Those are the LPG stations that are also where they have other activities like the fuel. They are selling petrol. The third one is the reseller. That is the category D, and they are 78 in number. This is the location of the LPG service stations in the study area. From the location. Yeah, thank you. So from the location, we could see that most of these retail stations are in the same area. The blue house signifies the OAU, and the circle there signifies OAUTHC. So all of these are all considered in the same area, close to OAU and OAUTHC. That is to tell us that the people that are majorly using LPG as their cooking choice are those that are the enlightened ones in the area. They are the students, the civil servants, the people that are more educated and probably having more higher income level. The characteristics of the LPG facility in Ile-Ife, for the reseller, they are also buying from either the category A or the hard-on retail stations. So their own sales is also incorporated into the sales of the first 2 categories. So So the sales per month is 7,200 kg per month for the category A and 6,800 for the second category. And then their total monthly revenue is over 49 million for the category A.
Conclusion, please. Conclusion, please. Your time is up.
So the study assessed the strategic technological parameters of the LPG retail industry in Ile-Ife, and this is critical to the policy initiative in Osun State using an energy planning and technology foresight analysis framework. The study provided information on total cooking energy and LPG consumption in Ile-Ife. The total cooking energy demand per month was determined at 46.152 million BTU. And then the three major LPG facilities were the category A, the reseller category, which is the category D, and the other retail stations. And all these are the category D are the majority, which is 68% of the total LPG retail stations in the study area. The estimated monthly LPG sales and revenue was 131,600 kg per month and 151 million naira in cash. Thank you.
Thank you. There are some problems there, apart from slides, at least initial slides being different from the one she had. Look at the title. A strategic technological analysis of the LPG retail industry in Ile-Ife. What is a retail industry? LPG retail industry. What is LPG retail industry? Those are the ones selling this thing to us, am I right? Good. Now, that's what we want to analyze. The retail industry. Strategic technological analysis. So, those industries are the ones we are analyzing. You first tell us, what are they retailing? Yes, you did that. Now, the map you showed us showed the distribution of this, of the outlets, thank you. Population is different from population density. We need a map of Ile-Ife. Already we know the population. The population is just a figure. But population density, the distribution of this population, vis-a-vis the distribution of the outlets. Where we have concentration, higher density, for example, on campus, we may say we have a very high density, population density here. If you look at the students concentrated there, staff quarters also. The hostels outside near the campus. Now compare that density with what you will have in areas like maybe Opa. You see that density there may be lower. So how much of these outlets do you need there? Then you made another conclusion. Oh, well, you said something about the type of people that are using this thing. Maybe they are the what language did you use? The elite, so to say. Yes. Where are they concentrated? Looking at this population density vis-a-vis the distribution of the outlets. These are things to look at. Maybe you need to note all these things before you draw your conclusion. Now, the energy, this gas, you see in this part of the world, all we know is this LPG. Gas. Take your cylinder there, they refill it. That's what we are using. Maybe elsewhere, they have different types. Just like what we use for our vehicles, the petrol. There are different types elsewhere. Depending on the lead, this is one, some are leaded. For those of you that are using cars, if you look at the manual, they will tell you the type of this thing you should use. But here, it's only one, all of us, we are using. So we are looking at that. I think you need some work to do on this, especially looking at the title of the work. So that's my suggestion to you. Does anybody have one? Okay, only one person here.
In the retailers, did you consider all these single cylinder sellers in Ife? Oh, okay. And what's the number like? 78. Oh, okay. I wouldn't want to contest that information because I'm sure they should be more than 78. In my area alone, if not that we wage a war because we don't want them to bomb our community. They were going to almost 30 at a point in time. So if that community could have close to 30 pockets of those, I imagine what we'll have in Ife environments. And the second one is about the quality of the LPG. Do you consider the blending option? LPG blending, I mean, in terms of the type of LPG you are looking at. Did you consider that? So those are the clarifications I need to make, sir. Thank you.
Some outlets where there are some, they just buy one big cylinder and they feed it. And those, you consider those, wait, you will answer everything.
Thank you very much, the presenter. I'm also on the data. It's unfortunate, what we know is quite different from what you are presenting here. So probably the area of study is not the same. I don't live on campus, I live in town. People selling those category D, even 200-meter radius to my house, I can count 5. So I'm surprised coming here and telling us there are 78 in Ife. Then you also said the number of people in household is 6. I don't know what you mean by household. If you did where people are doing phase 1 and phase 2, so what can you say per household? What do you mean by household? Is it a family or you mean people living in a particular building? So I think there are a number of issues about the data used. You have to do a lot, on the data. Thank you very much.
Number 2.
And the slide 16, where you made mention of the figures. I want to know how the figures were achieved. The number of population, then the LPG consumption. Thank you.
For the first question, sir, or let me start it with the second to the last question. On the number per household, we did not assume the number per household, ma. We used available literature from the National Bureau of Statistics. For Osun State, it is 6 per household, and that is talking about family. So the 6 is what we use to divide the total population in the study area, and that's what gave us the number of households in the study area. Did I answer your question?
Not properly. Not satisfactory.
From literatures, it is 6 per household. Okay.
You see, the thing is this. One. No, sorry. No, let me correct you. You don't say literatures. You just say literature. Now, how old is the literature?
2022.
2022.
Yes,
see, that's what they are saying. But from what we are seeing, I don't think that information is correct. But definitely you have to go by the literature anyway. The only problem is it will affect your conclusion. It won't, because the density. Again, I mentioned something about density. The concentration. Because even these houses, we are saying in some areas, especially outskirts, you will see that houses are sparsely distributed, unlike here where we are squeezing. Look at our gate, for example. You is so densely populated, and the house density of houses itself is so high here.
Yeah.
Now, continue your answer.
All right. On the number of those in category D, the category D are those that their cylinder tanks are less than, they are between. This could be, they have cylinders like 5 kg, 12.5 kg, 25 kg, different cylinders, but at least not up to 500 kg. And the information we used is from the source of our data. We went to their association, and those are the registered ones. So those are the ones that we can work with. So we went to the registered one. We went to the LPG registered association in the study area. It's also part of the study. I listed it as part of where the data was collected. So that is why we have 78. So there could be other ones that are probably having just 150 kg cylinder, which is not registered and does not even have the license from the DPR. So we went to the licensed LPG retail centers. Those are the ones we went to.
Okay.
So on the part of the population.
Please be fast, we are running out of time.
Sorry, let me just quickly add this. Talking about the household.
Your name, please.
I'm Bakari Oladimiji, sir. This is not household that she is trying to say. We're talking about occupants of the house. Because in the research, we are trying to get the number of households we have in Ife based on the population. We have a population of 476. Now, from literature, it is assumed, it is stated in literature that a typical family in an African state is around 6 occupants in the family. So when you divide that by the population, you can have the number of households in Ife. Then talking about the density, so we are not really, I think this research actually sets out to determine not the density and not the household. What we are looking at is, we are looking at one, how are they using clean energy? Then two, if a particular number is using this amount of clean energy, that means the remaining people are using biomass, probably. So we want to know how can we mitigate against this by making policy recommendations. That is the essence of this research, not the household or not the density. Though it may be important, which we are going to look into. Thank you.
Thank you. Thank you. I notice that you have lots of work to do. Please, on that work. Because what you said is your focus now. We require the economic situation of these households or houses, as you said, because you may have more than one actually. They are referring to families. And the figure they are giving is not realistic for in an African setting. 6 people in a family on the average. No. Father, mother, and 4 children. No. Don't forget you have your cousin with you, you have your nephew with you, and things like that. It's not realistic in an African